Well, hello there and welcome back to Adrian's Digital Basement. For today's video, we have a 1541 disk drive repair video. It's the first I've ever done, and we'll be working on the 1541 that I got from Desi in Lincoln City, Oregon. Let's get right to it. Right here is obviously a 1541, a very dirty 1541. It's like someone has done some mods. There's a little square hole there. And on the side of the drive, there's also a rectangular hole, very nicely cut. But this thing is very, very dirty. Let's take a look at this disk drive. I just want to see if it powers on. You can tell a lot about a 1541 by how it powers up. Let's just see what happens. Yeah, so this indicates some type of a fault. The red LED is on and this thing is just spinning. And it hasn't stopped. It should just come on, spin for a second, and then stop. Let's just open up this 1541 disk drive and take a look, see what's inside of this thing, see why it might be busted. I was trying to undo screws, but there are no screws in this thing. It already had the screws removed. Well, it's a 1541 short board, and considering there's all these holes for various mods, this board is looking pretty bog standard. I'm seeing absolutely nothing different and custom on here. Now it is not working, so I'm wondering if someone sort of swapped this board with a different one, or I don't know what's going on. But other than just being dirty, it all looks pretty much bone stock. I don't see any kind of wires modded onto the drive select spots here, so yeah, that's interesting. The 6522 chip here is from 1989, so this has been replaced. This here is from 84. The 6502 is from 82. This seems to be a little bit of a hodgepodge of things that are sort of switched all over. This IC is 84, 84, 84. But it's obviously someone's been in here working at some point, switching some of these chips out. So I took the entire chassis out of the case, and I've also dismounted the motherboard. So something happened before I was filming. While it was still mounted in the case, I had the power connected and it was turned on. And strange is when the drive powered up, the red LED came on, but it wasn't spinning, which was different than it was doing earlier when we were testing. The drive was still totally together. Well, it was sitting there on the bench, and after a little bit of time, some smoke started coming out of it. Uh-oh. And while it was smoking, I just took a look, and the part that was smoking was right here. It's marked C21 on the board, and it's a tantalum capacitor. And if you've seen my previous videos, or you just know of what tantalums do, they have a tendency to short out. Let's take a look at the schematics for this particular disk drive. So this board uses 251-748 as the schematics because it's actually 250-446. The PCB number is written right here and it's 250-442. And it says right here that this schematic is good for 250-442. Looking around on the board, there is C21, which is the one that blew up. And as you can see, it goes between 12 volts and ground. Typically, that is what a tantalum does. And that obviously shorted out internally, and it overheated and blew up, smoked. So the very first thing I need to do before we do any more troubleshooting is I'm going to need to unplug this, and we're going to have to cut that out and install a new tantalum capacitor. Back to the service manual, we need to look up what C21 is. C21 tantalum, 4.7 microfarad, 25 volts. So I need to replace it with something similar or higher voltage than that. Here I have a box full of tantalums. So I've labeled what they are. And just for my ease of use, this row here, I put little arrows to say that these are the ones that represent these. And 4.7 microfarad is right up here. I don't feel like getting the desoldering iron out, so I'm just going to use some solder braid here to get this out of here. There we go. I'm gonna hold it with my thumb, bend the pins on the bottom side so it doesn't fall out, and we'll just zap this baby in. And what's left is to crop off the legs, which one of them just went flying. Before we test this out, I was just taking a look at the bottom of the board. Generally looks okay. There's a little bit of rework that's been done. This IC right here has been swapped out and it's looking rather ugly what's happening down here. A lot of flux that's kind of dried and gotten crusty. It's this part right here. So it's in a socket, which obviously was installed after the fact. And it's some type of chip that says SK/4 LS123. So right off the bat, that's suspect to me that might have failed, causing the problems that this drive is having. And I'm just going to spray a little IP on here, clean it up, so I can kind of see what's going on. It's really crusty with flux. I need to blow away the soot that's on here. Okay, let's see what happens when we turn this on. All right, the drive is spinning, so that's a good sign. So we're getting 12 volts, or at least we're getting some kind of voltage. I wanted to check that the regulators were working correctly so that this tantalum here is seeing the correct 12 volts. 11.758 volts, so 12 volts is looking okay. And we'll check a logic chip, make sure that it's getting a nice solid 5 volts. 5.04, so that looks absolutely fine. But the red light is on, the drive is spinning, it's not stopping. So there's something faulty here going on, which is kind of an obvious thing. I think the first thing I'm going to do is pull out all the socketed chips and I will put them back in, just sort of deoxit. This drive is dirty. You know me with my deoxit, I love it. Okay, actually, hold on a second. So I was checking the schematics and see here it says Neutronics, short J6, Alps, J6 is open. Well, J6 on this board is a jumper link. Hopefully it's not out of focus, but J6 is there and is currently enabled. Well, Neutronics, it should be shorted. Alps, it should be open. I'm quite positive that this here is an Alps Mechanism. This is the type that you pop down like this, which is sort of the more common, at least what I've found, of the drive mechanisms. This is an Alps Mechanism. It doesn't have a brand name anywhere on here. But I actually have another drive here, which has the other type of mechanism, the flip-up one. And look, it says Neutronics right there. And definitely J6 should be open for Alps drives and not closed. So I'm just going to cut it just like this, lift it out of its way. I'm not sure on these drives, if you have it set wrong, what the symptom is. But okay, so I've cut J6 and I moved the wire out of the way so it's not going to short. And let's turn this on and see if that makes any difference. So the light's on, but it's not spinning. Wait a second. Before I cut that jumper, I had pulled this one IC out of this socket right here. So let's deoxit this socket and reinstall this IC. All right, drive is spinning again. So definitely that IC is necessary for that, but it's still just, the light is solid. It's not stopping. You can kind of hear that, the noise it's making there. So, all right. That was an unrelated issue, this jumper. And I don't know. I mean, how important is it to have that jumper cut when you're using the Alps Mechanism versus the Neutronics? I actually didn't even know that was a thing. I thought these were all interchangeable. But apparently with this type of board, you do need to set the jumper appropriately. Well, at least according to the schematics. Okay, I've removed all of the socketed ICs. And you know what it is. If you're doing the drinking game, it's time to take another drink. It's time for deoxit. And just for good measure, I'm going to use this toothbrush to really rub it into the pins of the sockets. All right, I've broken out the oscilloscope and I have the schematics over here on the iPad and the board is here. I have ground hooked up to the 6502 and it's time to start checking some of these signals. First thing we have to think about is that this is an actual computer, the disk drive, that has RAM and ROM and two 6522 I/O chips and the CPU. So if anything's not happening correctly on the CPU, like the reset line's not being brought high, it's gonna keep this thing from operating at all. And I've been chatting with the repair expert IZ8DWF from Italy. He is so good at fixing all these old Commodore machines, including disk drives. So he's given me some really good tips on where to start to diagnose this drive. He has a great channel where he repairs all sorts of Commodore stuff, including his recent excellent repair on a Commodore 1540 longboard disk drive. So I'll put a link in the description. Definitely check out his channel. Okay, I'm going to power on the drive.
and it's doing that spinning thing. Now, he told me that the default state of a 1541 is the drive to spin and the disk drive LED to be on. That is how it's going to be until the CPU initializes the I/O chips, which stops the drive from spinning and turns off the light. So if you're in this state, it could be pretty much anything on the board that has to do with the execution of code for the CPU. So the ROMs, the RAMs, it could be the I/O chips, could be the data bus, could be the CPU itself. It just could be all sorts of different things. So the first thing we need to do is start by checking the signals to the 6502 CPU. So first off, I'm going to check the clock signal. Okay, I broke out the oscilloscope, and I have the drive here, and I have this iPad with the schematics, and I was going to start showing you how to troubleshoot the drive, and I was just having all sorts of problems on my oscilloscope measuring the signal. And it turns out that the little ground probe, which connects up to my oscilloscope probe, just like this, that this part went bad. And there's a break in here. I thought maybe it was inside this clip right here, but it's not. I tested continuity from this little metal clamp to the wire right there and nothing. So there seems to be a break somewhere inside of this thing, like in here or I don't know. And this was causing crazy measurement issues with my oscilloscope. I was just getting really unusual things that just didn't make sense. So that's a first for me. This is the actual Rigol probe part that came with my oscilloscope probe too, and it's bad. Now, lucky for me, I have the little parts kit that came with the oscilloscope, and in here I have the other ground probes, because I didn't end up using them. Oh wait, this is actually for a different probe set. Here we go. Here's another bag of parts. These have the extra ground straps in here, so here's another one. Okay, so I have the multimeter on resistance. So when I put the probes together, yeah, we're getting 0.0 something or other ohms. I'll clamp this one on that side, and I'll hold this on. And there we go, 0.0, looking good. And we'll take this one, which I think is bad, we'll clamp that on there, hold that on there, and look, nothing at all. This died. Wow. So I'm curious if any of my viewers have had this issue where these things die like that in a non-obvious way, where none of the wire is frayed or cut or anything. The wire all looks absolutely perfect. So that's really annoying. I spent quite a bit of time trying to figure out what the heck was going on, and it turned out that it's just bad. All right, here we go. Power on the disk drive. So it's spinning, and let's check pin 3 for the clock. Very nice. We got a perfect 1 megahertz clock signal there. It looks totally sharp and nice. There is an output of the clock signal or a second phase here on pin 37, and that also looks good. We're looking at 1 megahertz, which is perfect. So we know the clocks are good. Reset signal. This is reset, pin 40. So when I turn the drive off, it'll go to low, and when I turn it back on, it should stay low for a second and then go high. There we go. It went low, high. If it was staying low, it would keep the CPU permanently reset and it would never execute any code. Also on the CPU are the interrupt and the non-maskable interrupt lines. So that's pin 4, which is high, and pin 6, which is also high. If either of these were held low continually, that could mean that the CPU also is not running, depending on what code is executed and how those are set up. So those look absolutely good. So we're on pin 34, which is read-write pin. If I turn this on, it just goes high, and it's not pulsing. This is, as the CPU reads and writes from the RAM, this will be pulsing up and down, and it's just sitting there doing nothing. Okay, the probe is on 6502 pin 25, which is address line 15. When you first initialize a 6502, it has the reset vector, which just goes to memory location FFFF, which is in ROM, and it starts executing the code. And if I turn this on, so we're just getting a high, which means the CPU is trying to read in the F location. Now, if I go down these pins and I look at the other address lines, I actually see no activity. Every single one I touch is just high. So I'm kind of going through them. High, high, high. So that's not normal. On a 6502, what happens is when it first initializes, it goes to FFFF, tries to read out of the ROM, and then it starts to execute, usually jumps to a different location. And you'll see activity on the address lines as it's reading the ROM and moving through the different parts of memory. Nothing is happening whatsoever. It's just sitting here all doing nothing. And then if I look at the data bit lines, like there's 0 and 1, they're also just sitting there at high. Oh, that one's low. But that would be explained if the CPU is pointing to the ROM chip and trying to read out the ROM chip. So the fact that the data lines have no activity, they're just sort of frozen in time, either high or low, really implies that the CPU is not executing anything. So looking at the schematics on the iPad, there are 2 ROM chips on this, which are these 2 chips here, and their chip select lines are driven off of these simple decoding logic right here with these logic chips. Let me just quickly check to see that the correct ROM is being selected. As you start to go to that initial FFFF location in memory, the correct ROM needs to be selected so that it will read out its contents to give back to the CPU. Okay, and with the 2 ROM chips, it's pin 20 as the chip select line. And at any given time, only one chip should ever be selected at a given time. If the decoding logic that decodes which ROM or which RAM should be selected is screwed up somehow, then we might have multiple chips selected. Right now, this ROM chip has a high input signal on the chip select line, which means it's not selected, so it's disconnected from the bus. And then this ROM chip right here is currently low, which means it is being selected. And when you look up what this ROM chip is, 901.22905, this is the upper ROM chip, the one that contains the code at FFFF that executes when you first power on the drive. So it's being selected, but because no address line activity is happening, it's just frozen in time, this thing is just outputting one solid set of data bits, which I see on the bus because some are high and some are low, and that's all that's happening. Nothing is moving. So with that said, I think my hunch is that the CPU is probably bad. With the clock signal being good and the reset line being good going into it, it should be executing code. We should be seeing strobing on those address lines as it runs through the memory. And we're not seeing that. The ROM seems to be being selected correctly, but the CPU just doesn't seem to be doing anything. But the thing is, because I went through and checked all the address bus lines and all the data bus lines, none of them look screwed up. If some of them were like in the middle, like they weren't 0 or they weren't 5 volts, so they were like at 2 volts or 3 volts, that would imply there might be some kind of a conflict or one of these other chips might be bad. But all the address and data bus lines look good. So that's always a good thing to check when you're diagnosing something like this. Okay, so I think it's time to swap out this CPU and let's see what happens. Now, I'm going to say that 6502 CPUs are pretty reliable, even the Commodore MOS ones like this. 6502B from the 46th week of 1982. The chip is physically in decent shape. It's made in Hong Kong. But let's put this aside. And I went into my parts bin and I dug out this 6502. It's from 1985, so it's a little bit newer. But it's a MOS original part. So new CPU is in. Here's the old one right here. And let's power this up and see what happens. Oh, look at that. The drive stopped spinning. The light is off as well. All right, the ground is hooked back up. The CPU is in there. Let's go check the address bus lines and see their activity. I mean, the drive, I think, should be working now. We'll have to plug it into a computer to check. But let's just double check what the activity looks like on the bus. So that's address line 0. And as you see on the scope, that is normal activity on the address lines. It's going through and it's doing stuff. And I'll just quickly check some of the other ones. Yep, it all seems like it's executing code right now. It's running. Okay, and now we're on the data bus, and also activity looks completely normal on the data bus lines. This is how it should be. And if I turn it off and I turn it back on, you'll see it should be idle for a second as it's in reset, and then it will start executing. Yep, there we go. Totally normal activity now. So there we go. At least so far, the CPU was a bad part, and this appears to be executing. So I think before we test this on a computer, I'm going to power it off, and I'm going to lift the board off the machine. And I'm going to spend a little bit of time cleaning inside of the disk drive here, because this is looking a little crusty in here, and it really could use a good cleaning. All right, first up, I have a little IPA on this cotton swab here, so I'm just going to lift the heads and clean the head, although actually I got to say, heads look really, really clean. Sorry, I'm not getting a good view of this for you, but it's nice and clean. Commodore disk drives are single-sided, so this top part is just a little pressure pad. It doesn't actually do anything when it comes to reading the disks. Just don't lift this little lever up too high when you're using the cotton swab to clean the heads. Next up, we have the movements of the head, and actually it seems to be moving quite freely. But I'm going to take some silicone here and I'm going to put that on a cotton swab, dab this on, and then I am going to rub that on these little sliders that are in the drive here. I'm going to move the heads back and forth and actually get on here. When you move the heads, it sort of exposes a little bit more of the rails. So just try to get as much of this on there, kind of give it a little lubrication, and then move the heads back and forth manually like this. Just make sure it's nice and smooth operation, which it is. A little bit more of the silicone here. I'm going to put some up here on this little metal part here. This is what the head slides on when the drive is not in the down position. See how it works? Okay, I have a random floppy disk here. Let's insert this in. There it is in, and pops out. Good. So this appears, at least mechanically, it's working okay. Now right under here is where it clamps the disc. So this top part clamps the disc onto this lower area. I actually like to use a little cleaner and just give this a bit of clean. This needs to be not greasy or slippery, or the disc is going to slip inside the drive. So it's pretty clean right now, to be honest. I just sort of use a cotton swab with some cleaner on it, and you don't want to use any oil or anything on this. This needs to be able to grip the disc firmly. Otherwise, it will slip in there, and you'll have trouble reading discs. And what's happening is the actual disc is not spinning inside the sleeve, because there's quite a bit of resistance, to spin it. So this has to be able to clamp it with enough force. So just sometimes if you're having trouble, you might have dripped a little bit of lubricant onto that area, and then that will cause that issue. So I noticed one thing is this is pretty noisy when I turn on the drive. Listen. Kind of makes some crusty noise, and that's this whole assembly right here on the top that's spinning. So I'm going to take some silicone grease specifically. I'm just going to dab a tiny bit right on here on this little spinny part on the top. Basically, you don't want to use something that's too liquidy like this stuff, because it might drip down onto the drive and the disc below, and that gets that whole thing slippery. Let me turn this off. See if it's quieter. No, it's not really quieter. I'm going to put a tiny drop of the silicone right there to try to get that to work in a little bit. And I'm just going to give this a little clean on the front panel, because the whole thing is pretty filthy. Oh yeah, that's a dusty drive. Now that looks good now. This looks pretty clean. Probably could use a little 303 to restore the luster of the plastic, but this mechanism goes in and out much nicer than it was. Plus it's nice and clean. Okay, time for testing. I have the computer hooked up to the PVM over here. I have my ZIF machine. Let's power this thing on. Okay, looks good. Light turned off. Turn the computer on. All right, let's go into Jiffy DOS. First off, I'm going to hit the @ symbol, which will tell us the error channel, and I am seeing Commodore DOS version 2.6 1541. So this drive is talking at least over the IEC to the 64 without issue. So I have a floppy disk. We have Ultima 6. Stick this in. We're just going to go right for broke. Load, comma 8. It says ready. Hit run. Oh. Actually, I think this one has to be load star, comma 8, comma 1 for it to work properly. Light's blinking, but that's what the fast loader does on Ultima. So this is still a little bit noisy here. A little clunky sounding, but whatever. It's seemingly reading the disc fine. Let's hook up the audio. Oh, listen. Haha! Lord British presents. So I'll turn the volume down. So that's amazing. This drive seems to be working. Now, a full test would involve formatting and reading and writing a disk. So let me quickly do that before I declare this good. But for sure, I can say that this CPU is faulty. 6502, bad. Wow, I don't think I've ever had a 6502 go bad. But hey, that's pretty nice that this was the only fault. But remember, I had pointed out that this had already had a 6522 replaced. That's this chip right here. And also this chip here had been replaced, which is the LS123. Now this chip wouldn't prevent the drive from booting up, where I could communicate with the computer, but I think it would interfere with the reading of the disk if this chip were bad. So that chip does seem to be working okay at the moment. Now on the Easy Flash, I actually have some 1541 diagnostics on here. It's a diagnostic cartridge, and I loaded that onto here. It has alignment check and show BAM and some other things. So let's see if we do show BAM. That's sort of like the allocation table on the drive. Yeah, it's reading that without an issue. I'm going to stick this blank disk into the drive. That way we can see if it's formatting and reading and writing properly. There's a S for speed check option here. Speed check, press return. This is telling me that it should be 300 RPM, but it's 297 or 298. So it's a little bit under, but I think that's close enough for it to work properly. Oh, this is so noisy, this clamp thing on the top here. I think I might try to take this apart because this is annoying. This is annoying to use this because it sounds so crappy. All right, I'm not too familiar with this. I took the screw out here on this, and I took this little circlip off. So I usually take a little piece of tape and I cover this up, and then I use these like pick tools to get it off. And the tape just helps it not go flying off into the distance of the room to never be found again. I can lift this off. I guess I didn't need to take that screw off. There's some glue there. I'm just going to leave that in place. Okay, look, and when I lift this up, I think I need to take the faceplate of the drive off. And that will allow this part to come up so I can lift that up more to get that mechanism underneath there out. There's like a spring and the clamp and all that stuff. So now this faceplate should come out. I think the LED is still connected there. So now I can lift this up a little bit more. And this whole clamp mechanism is just sitting down in here. And there it is. Yeah, this looks really crusty. Like whatever lubricant was on here at one point, kind of rusted and got gross. That's probably why this is so noisy. I'm going to clean this up with a little alcohol, get this kind of crusty grease off here, and then I'll try to re-lubricate it. All right, it's back together. I actually put that clip on first without putting this little top cover back on. But the question is when I turn this on, will it be quiet now? I cleaned all the little parts and I used this silicone grease on them when I reassembled it, and let's turn it on. Nice, much quieter. It's still not probably as quiet as I'd like it, but there's a little bit of corrosion inside there I can't get rid of, but it's a lot better than it was, that's for sure. In fact, let's put a floppy disk in, turn on the computer, and I'm going to do a performance test, which is going to put this thing through its paces, see if it's working. Yeah, and this sounds a whole lot better. There's a little bit of noise here and there, a little tick sound, but it's not doing horribleness. All right, so it passed its performance test without issue. This formats the disk, reads and writes a bunch of files onto it, does a bunch of tests. Everything passed without issue. So thumbs up, this drive is fully functional. Well, that's going to be it for this video. You may have noticed I actually put the mechanism into a white 1541C drive case, and that's because of an upcoming project I'm working on where this better suits the color of the machine I'm going to be using this with. So it was a bad 6502 processor and a bad tantalum capacitor that brought this drive down, but it's back and working better than ever. I've actually left the drive turned on for the past several hours, and it's still working perfectly. I just loaded up Odell Lake on this Commodore 64, so couldn't be happier with this disk drive now. If you like this video, I'd appreciate if you can give me a thumbs up on this video. If you didn't though, you know what to do. You can hit that thumbs down button. Definitely you can subscribe for more videos. There'll be lots more in the future, especially troubleshooting videos, which lots of people seem to like. And I'd love it if you put your comments and your suggestions down in the comment section below. I read all those comments. And thank you very much for watching. I will see you next time. Goodbye.